Hi, my name's Aaron, and I do not study permafrost. I focus on buildings. I'm a building physics person. I'm a construction manager and an architect, and I focus on deployment. So generally, what I focus on is taking technologies that have shown promise in the lab or in the mock-up setting and applying them to real places with real humans in them and with real trades, and trying to find trades that can pick up these technologies and run with them, find communities, municipalities, and tribes that are interested in applying them. I'm based out of Fairbanks. And I'm going to skip this slide because you all know where this is and we don't need to, right? I live in an experimental house with an experimental foundation with an experimental heating system. My house is the yellow one in the top left. I work on, we have two different foundations for these four houses. The ones on the right are on pile foundations. The ones on the left are on a insulated foundation. That insulation, what we tried to do was do an experiment where before we put down the insulated foundation, on the top right photo, you'll see a piece of black pipe where we ran ABS pipe in the ground underneath the foundation. Every winter, when the mean temperature is below freezing, I uncap that pipe and I use a little fan like you'd use for radon, and I pump cold air underneath the house, underneath the thermal envelope, to try and keep the ground cold. And then every spring, before breakup, when the mean temperature before it gets above freezing, I cap that pipe. And that is because I live on permafrost that is minus 0.5 degrees. And it's going to go in my life. It's going to go in my career, probably, in my productive years. And so it's a great place to be part lab coat and part lab rat. And we have one of the two that has not moved and one of the two that has moved, that we have proven out a technique of spray jacking the foundation back in place. It's fun, it's interesting to me, and I enjoy it. But it is not for everyone. Good research and innovation in Alaska is on one thing more than our engineering skill and our design skill. Good research and innovation is based on consent. And when you do housing design and you're trying to change the way that we design houses, you need people that are interested in the research that are going to live in that house. And so what does that mean? It means you operate between two somewhat rigid parameters. On one end, you have a municipality or a resident or a tribe that is not interested in being experimented upon, perhaps. And if they say so, we should say, then we will not. And then on the other side, you have the reality that, so I live in an experimental house. My colleague Robin lives in an experimental house. Our center director Bruno lives in an experimental house. Our mentor and teacher Jack lives in an experimental house. We all look pretty much the same. So if on the other side, if we only are experimenting on building physicist's house, then we will disproportionately be able to innovate. That innovation will reach people disproportionately in our state. And that should bother us just as much as some of the past where we experimented on people without their consent. Within those two parameters, we can find innovators either amongst communities, amongst tribes, or amongst individuals within communities that are interested in being part of innovation. And that should happen before we choose our systems, before we choose what we want to look at. So what I'm going to show you today are systems that were selected by communities, by governments, by municipalities, or even by individuals that address the issues of innovation and experimentation that are the most interesting to them. So not our journal publishers, not our funders, but the people that are going to live in the houses, the problems that we're going to try and solve. And when you look at that, you're going to see a couple trends. One is things get lower tech, because the most empowering thing if you live in a home that is experimental or innovative is the homeowner wants to be able to adjust that home. They want to be able to use that technology. That is more empowering than me getting on a plane, going to the house, with my thermistor readers, with my laser levels. And so we take that idea and we push it towards the people that are going to benefit from it. Then they are more willing to bear the risk that me and my wife bear in my house when I look at the level of risk I want to take in my house. So well, it doesn't show the I shouldn't have put that at the top. I should have put that at the bottom with the Zoom screen. But I think in the face of unpredictability, all of our foundations should be adjustable in the residential world. We should, whatever system that we use for a foundation, it should be adjustable. And I think it should be adjustable by the homeowner without heavy equipment. And I'm not a salesman for any particular type of foundation, because any type, and same goes for sewer system or structural system, anything that I can show you today, you'll be able to find a place where that wouldn't work or it has failed. And the reason is, with the current state of permafrost, we are fighting a losing war when it comes to residential construction. So we've got to be careful about where we put our foundations and what we do. But if our foundations, no matter what system we go with, whether it's piles or pads or rafts or anything, it should be adjustable, and it should be adjustable by the occupant. And if that's where we start a design specification, then we're going to get more agreement from people that are willing to try new types of foundations. And adjustability is not only in a foundation, it should be anywhere the building meets the land. That stairway on the left is one of the most common sites on permafrost in Alaska. It's where a porch, which is unheated, or a stairway comes off of a building that is heated. And so I think all connections that touch the land should be hinged, and they should be adjustable to the foundation. And that's, again, not a product or a technique, it's a design methodology that we should be doing. This hinge can be fabricated for less than $1,000. And every house in Alaska on permafrost should have something like this. It doesn't have to be this design, it doesn't have to be our drawing, but it should be something that can hinge. I also think that in the face of unpredictability, we should all plan for expansion. This building in Chile is a design that I blatantly ripped off from a Chilean architect, where they created part of a building where all the systems were in place, and then a gap where the occupant could add on whatever is most important to them in that building. I always thought that was brilliant. And then we thought, well, how on earth would we do that on permafrost? Because whenever you add on to a building on permafrost, you are creating a hinge point, you're creating a difference in the time scale of when you've disturbed the soil, you're creating a problem. However, we deal with so much overcrowding, so many large families and people per square foot. We really should be planning somehow to plan for expansion. And I think the cheapest way to do that is by creating our foundations with larger decks that are able to be built upon afterwards, should a building want to be expanded upon. So with the tribe of Mountain Village, they wanted a house for homeless individuals that could be expanded upon when they came out of homelessness, when their economic situation improved. So what we wanted to do was it looks like a kind of an ample deck, a very large deck you can see on the left. The important part is the deck and the rest of the house were all built on the same foundation at the same time, and for minimal money, because there's nothing on that deck. All you need is a little treated wood and a couple more of the jackable posts. However, as you can see on the bottom, if you want to add on to that deck, you don't have to create more foundation, more insulation, and more structure to make that addition later. So you can create less expensive structures that will not paint themselves in a corner if a family wants to grow. And that was what was most important to that tribe, to that community. That's where they wanted to experiment. We had other experiments that we were interested in and they weren't. And so we had to say, well, if this is your emphasis, then this is what we do. This is where our research is led, not by any other metric, really. The same goes with lateral movement. So if I believe that all foundations today, all new foundations for light construction or residential should be able to move in the y-axis, I also think that they should have to move in the x-axis. I think we should be creating homes that can be relocated. This project is in Utiqiagvik, which is the new village site for the village of Utiqiagvik, we had to, well, we still have to get roughly 400 people across to safety from a site that's no longer safe. And that the speed of erosion, as the erosion experts will tell you, is moving faster than the speed of land permitting or platting can go. We needed to be able to build homes before they were platted. Because if you think that permafrost is hard to deal with, try government zoning and platting. And so we needed to create a situation where we could create buildings that we knew were going to be moved, not just in case they're going to be moved. Like you can create a foundation where someday you might have to move, but it's more robust if we built our foundations so we know we're going to move them. Because anyone who's tried to tow a house knows that if you don't design it to be towed, it takes a hell of a beating when you tow it. You get cracks, you get issues with the windows. We've got to design our homes to be towed so that they don't get destroyed in the towing. And that's not just in the foundation, that's in the structure, that's in the trusses that we choose, it's in the way we tie our trusses together. If a community, or if you live in a home that can move laterally, that can move vertically, no matter what system you end up choosing, that homeowner has more confidence that they're going to be able to live in that home for their life or for their children's lives. We should be building that in. This is a separate project in Utiqiagvik, up the coast, down the river and up the coast from Mountain Village. They also have to move, but they don't have to move today. They're doing a managed retreat where all new buildings are going to go up the hill to safety. However, the densely populated Old Town, anything that gets built in Old Town should be moved for that big someday, whenever the last big storm comes and they've got to get off the barrier island and up the hill. And same thing. It doesn't matter which solution you choose or which solution that the tribe or the municipality is interested in. What matters is that if you're putting money into a new house, you're putting money into a house that can move when it needs to, if it needs to, so that you can be part of that long-term plan. One of the things that was different about Utiqiagvik is that they didn't, let's say you've got water and sewer in Old Town and you have to switch to a different system when you go up the hill because there's very little left. There's very little infrastructure that's going to be in a pioneer village. If you waited till all the infrastructure was in before people moved in, you'd never get there. So you need pioneer houses that can go up. So what we did was we built a kitchen and bathroom and mechanical room in a container. Utiqiagvik has plenty of good carpenters, plenty of good operators, they have good foremen. They don't have a plumber and they don't have an electrician. So we took those materials that are most expensive, that are already not jobs that people in the community have. We built that in the lab. We sent just that part out, and then we put it on this movable foundation. Because one thing you don't want to do, I know that prefabricated architecture allows you to save costs, but in a housing crisis where you have a housing shortage, but you also have a job shortage, we can't go fully modular and solve the housing shortage problem by exacerbating the job shortage problem. And so we just take the jobs that don't have local people to take them, just build that part, send it out. All those operators, carpenters, and foremen have a job in the community, building the house around the shipping container that can operate either in the water sewer system on Old Town or go up the hill and operate on a pioneer system. This is a house some of us saw today. This is a skidded house that TNH is pioneering here. I think TNH is doing amazing work. They're dealing with some pretty serious problems. I think that it doesn't look anything like the projects that I've showed you that we've designed in the lab, but it has these same ideas behind them. This can move laterally if it needs to. This can move vertically if it needs to. The exact technology is less important than the fact that all new buildings coming out have this capacity. And the same can be done with water sewer. So we shouldn't say, should linear water sewer be the way, or should decentralized water sewer be the way? We should just say yes. If a community wants decentralized water and sewer, we need an answer. If they need linear, we need an answer. That idea of consent. What type of system does a community want to research? What do they want to innovate in? We start with that, and then we start going down the line of, well, what's a better linear water sewer system look like? What's a better decentralized sewer system look like? And in the face of unpredictability, what solutions have we not yet tried? I mean, that's Yellowknife. This is Yellowknife, which doesn't have enough space on the rock. That has not enough space for the current settlement. They have elected something that is rather radical, I think. Now, I would not push this on the tundra villages like Kasigaluk or Napachuk or Moutluk, although it would be a great place for this type of thing. But I am waiting for a community to come to me and say, have you thought about what we could do on tundra ponds? And I would say, I have thought about that. If you're interested in a research experiment like this, then let's do this together. And that's it. That's all I have on that.